This is solution tutorial class where we solve mathematical problems. So any problem we have, we are going to solve it in this class. So what we have today is calculus. Calculus is a branch of mathematics where we solve some further mathematics. So the topic we are going to consider today is differentiation from first principle. Let us consider how to solve problems under differentiation. So number one, question number one. If you are asked to find from first principle dy over dx, that is the differentiation of the following. Number A, y is 4x raised to power 3 plus 2x raised to power 2 minus 5x plus 7. Let us see how to differentiate this. After this one, we'll go to another one. So if you want to differentiate a problem like this from first principle, all you need to know is to follow the steps. So you write solution, showing that you have started solving your problem. So the first step is any place you see, you write exactly the question that is given to you. So you write y is equal to 4x raised to the power 3 plus 2x raised to the power 2 minus 5x plus 7. So you call it equation 1. So the next step is what? Any place you see 1, you will add delta or change in 1. Any place you see x, you will add plus change in x. See it here, like this place now. This is 1. You say y plus, if I like, I can say change in 1. Or you can call it delta 1. Will be equal to 4 into x plus change in x raised to the power what? 3. You also come here and write 2 into x plus change in x raised to the power 2 minus 5x plus change in x, then plus 7. I will write this plus 7 because there is no s there. Yes. So the next thing you will do, you will now expand this. You expand the bracket. So any place you see, maybe if you have bracket now, you have 2 terms there. If the power is 1, like here now, the power is 1, you are free to open the bracket. But if the power is not 1, you will go to another topic, which we are going to show you in another place. Binomial expansion. Because you have 2 terms and it has power. So you're going to use binomial expansion. In binomial expansion, maybe let me go to rough. So you're going to expand this. So the next thing you write now is saying, because of that, let's call this equation 2. So we now say expanding those ones that have power. S plus change in s raised to the power 3 and s plus change in s raised to the power 2 binomially, meaning using binomial expansion. So what I will do, let us see how to expand this to binomially. So if you want to expand it binomially, we can say, let us use the Pascal's triangle method. Using Pascal's triangle method. Using Pascal's triangle method. So if you want to use Pascal's triangle method, the first thing you do is to draw the triangle first. How do you draw the triangle? So that method says that, for example, if you have something like this, x plus y raised to the power n, that all you need to do is to draw a particular triangle. So we now draw the triangle. So when this power n is 0, you write 1 on the triangle. So watch very well so that you learn to draw the triangle. So when the power is 1, when this power is 1, what do you write? You write 1, 1. When the power is 2, you will now say 1 plus 1, it will give you 2. Then 1, 1. When the power is 3, we have 1 plus 2 is 3. 2 plus 1, 3. 1, 1. When the power is 4, we write 1 plus 3 is what? 4. 3 plus 3 is what? 6. 3 plus 1 is what? 4. 1, 1. Just like that. But I'm going to stop here because the two I want to expand is when you have s raised to the power 3 and s raised to the power 2. So let us now see how we can use binomial Pascal's triangle to expand this. So if I want to expand this, it's very easy, very simple. So all you need to do is to say s plus delta s raised to the power 3. S plus delta s raised to the power 3. You go to where n is 3, which is this place. This place now. You look at it, you see it. So this one and this one are the coefficients of this s and change in x. Coefficient simply means number in front of a variable. So because of this one, you will write this s plus. You write this 3, you combine these 2. So once you write 3, combine s and change in x. You say s change in s plus. You write this 3 again. You combine these 2. You combine s and change in x. So the next one is now 1. That one will be the quotient of the last term, which is
y dx.
x. So the next step is what? You go to the power of s. This is 3. So you raise the power of this s by 3. So the next s in the next term, it will be decreasing by 1. So the next s in the next term will now be 2. The next s will now be 1. But in mathematics, we don't write raised to the power 1. Do the same thing to delta s or change in s. So you now say that this change in s, you write raised to the power 3. The next change in s will now be raised to the power 2. The next change in s will now be raised to the power 1, but you don't write raised to the power 1. So if you expand this binomial using Pascal triangle, this will be as. Let us also expand this one, because these are the two terms that will give us problem, because you cannot expand without removing these powers. So if you pick s plus delta s raised to the power 2, what will it give you? You go to your triangle again. That place you have the power 2, see it here. So because of this one, you write s. You pick these 2 now, combine these 2. 2s change in s. Plus this one now will be the quotient of the delta s. So it's going to give you delta s. What do you do now? You go to the power of s, you say s raised to the power 2, the next s will be 1. Do the same thing to change in s. So the power of this change in s will be what? 2. The next one will be 1. I hope you are getting it. Okay. So what you now do, you will now substitute these values in equation 2. Because remember, we are not doing binomial expansion. What we are doing is a differentiation. So we now say substituting in equation 2. So you come to this equation 2. You start again. You write y plus change in y will be equal to 4 into. So instead of saying s plus change in s raised to the power 3, we are going to now write this. So when you write it, you have s raised to the power 3 plus 3s squared change in s plus 3s into change in s raised to the power 2 plus change in s raised to the power 3. So we are through with this one. So the next one is this. So you now have plus 2 into. So instead of writing this now, I'm going to write the law. So we are going to have s squared plus 2s changing s plus changing s is equal to 2. I'm through with that. But this one now, the power is already 1. So we can open the bracket. How do you open the bracket? To say this minus 5 times s will give you minus 5x. Minus 5 times change in s will give us what? Minus 5 change in s. Then you have 7. So we can continue. This one will now open this bracket. So we now have y plus change in y will be 4 times s raised to power 3 will give us 4 s raised to power 3 plus 4 times 3 will give us what? 12. So we have 12 s squared change in s. 4 times 3 will give us 12 s change in s raised to power what? 2. 4 times this will give us what? 4 into change in s raised to power 3. You now open this bracket. So you have plus 2 times s squared will give you what? 2s squared. 2 times 2, this 2 here now, is going to give you 4s change in s. 2 times this will give us what? 2 into change in s raised to power what? 2. Then how write the whole of this? You say minus 5s minus 5 change in s plus 7. This is where we are. So the next step will be for us to make this delta y or change in y the subject of the formula. Remember, we are looking for dy over dx. And this dy over dx is what we call differentiation. So for you to make dy the subject of the formula, this y will come over to this side. And when that happens, we are going to have that change in y will be equal to 4s raised to the power 3 plus 12s squared change in s plus 12s into change in s raised to the power 2, then plus 4s into change in s raised to the power 3 plus 2s squared plus 4s into change in s plus 2 into change in s squared, what again? Minus 5s minus 5 change in s plus 7. Then if this y comes over to this side, it's going to give you minus y. Then from equation 1, because equation 1 says that y is still the same thing as this. So what I will do, I will not say from equation 1, I will go back to equation 1. So if you go to equation 1, any place you see 1, you remove this 1 and put the value of 1. So this expression will now give us change in y will be equal to what? 4s raised to the power what? 4s raised to the power 3 plus 12s squared change in s plus 12s into change in s raised to the power 2 plus 4 into change in s raised to the power 3 plus 2s squared plus 4s change in s plus 2 into change in s raised to the power 2 minus 5s minus 5 change in s plus 7, then minus. So instead of writing this y now, what do? You go to equation 1 and pick the value of that y. And the value of that y there is what? 4s raised to the power 3 plus 2s raised to the power what? 2 minus 5s plus what? 7. So the next thing is that you open this bracket. Whenever minus is moving inside any bracket, that minus will change all the signs there. So if you have plus, the minus will change it to minus. If you have minus, the minus will change into what? Plus. So when you do that here now, we are going to have that change in y will be 4s raised to the power 3 plus 12s squared, change in s, plus 12s into change in s raised to the power 2, plus 4 into change in s raised to the power 3, plus 2s squared, plus 4s change in s, plus 2s change in s raised to the power 2, then minus 5s minus 5 change in s plus 7. So this minus will change all the signs here. So this will change this to minus 4s raised to the power 3. This will change this to what? Minus 2s squared. This will change this to plus 5s. This will change this to what? Minus 7. Then you are going to reduce. You discover that some will cancel some. So if you have plus 3 minus 3 is going to give you 0. So if you now watch 4s raised to the power 3 minus 4s raised to the power 3, it will give you 0. So this will remove this. What again? This one now will cancel this because this is 2s squared. This is minus 2s squared. So this one will cancel this. It will be 0. If something is 0, it is 0. Now, this minus 5s will cancel 5s and 7 will cancel 7. So the whole expression is reduced. You know, solving maths is when it's like when you have a problem, you try to reduce that problem into a simpler form. So you are trying to reduce it. So this big expression is now reduced to what? 12s raised to the power 2 change in s plus 12s change in s raised to the power 2 plus 4 into change in s raised to the power 3 plus 4s change in s plus 2 into change in s raised to the power 2 minus 5 change in s. So this is what you have. So the next step is now, remember we're looking for the y by the s. So the next step is, and once you have equality sign, for you to maintain that equality sign, whatever you do to the right hand side, you must do it to the left hand side. So because of that, you are going to say, dividing both sides by changing s. Remember, we're looking for the y over the s, so that at least you have change in y over change in s. So when you do that, you have change in y over change in s will give you. So we're going to divide this side 10 by 10. A 10 is separated from that 10 with plus or minus. So each 10 now, we're going to divide that 10 by change in s. So when you do that, you have 12s change in s, you divide it by change in s. That we are through with that term. You go to the next term. 12s into change in s raised to the power 2, you also divide it by change in s. You go to the next term, plus 4 into change in s raised to the power 3, divided by change in s. Step by step. Then plus 4s change in s divided by change in s plus 2 into change in s squared divided by change in s minus 5 into change in s divided by change in s. So the next step will be what? You now have change in y over change in s will be, this change in s will cancel this change in s. You will now have 12s squared plus, this change in s will cancel one of these, it will remain 2, because change in s squared means change in s times change in s. That is change in s into 2 places. So 1 will remove 1. So it will now, we now have 12s change in s plus, so this one will remove 1 from 3, it will remain 2 now. So you have this one, remove this, it will remain 2. So you have 4 interchanging s raised to power 2. Then plus this will cancel this. You now have 4s plus what again? This will cancel one of these. You have 2 interchanging s minus 5 because this will cancel this. So we are going to the next step. So the next step will be what? The next step will now be we take the limit of both sides as change in s tends to 0. That's the next step. So now say taking the limit of both sides as change in s tends to what? 0. So try to learn the steps. Take the limit of both sides as change in s tends to 0. It means any place you see this change in s, you put 0. You say taking the limit of both sides as change in s tends to 0. So what you are going to have will be, you see, limit of change in y over change in s as change in s tends to 0 will be equal to limit as change in s tends to 0. Then you will now write this expression that side. You write 12s raised to power 2 plus 12s change in s plus what again? Plus 4 interchanging s raised to power 2. Then plus 4s plus 2 interchanging s minus 5. Then as a rule, anytime you take the limit of change your y over change in s as change in s tends to 0, it means you will now have the y over the x, which is the same thing as differentiation, which is also the same thing as gradient, which is also the same thing as slope. So this is what they are looking for now. So the sign will now change, the y over the x, that is differentiation. Then what we are going to do this side is this. Any place we see change in s, we put 0. So if you come to, and if there is no change in s, you write the whatever you have. So if you come to the first term, there is no change in s, so you write 12s squared. Plus, you go to your second term, what you have there will be 12s. So this change in s will now be 0. You go to your third term, you have 4 into 0 squared plus 4s because there is no change in s here now. Then you now have plus 2 into 0 minus 5. So you now have that the y over the s will be 12s squared plus 0 because anything times 0 is 0. Plus 4 times 0 squared is 0. 0 times 4 is 0. Plus 4s plus 0 because 2 times 0 is 0 minus 5. So your final answer will now be 12s squared plus 4s squared minus 5. So this is how to differentiate any number from first principle with respect to s. Thank you very much. So the next video will now be how to differentiate trigonometric functions. So you're going to see how to differentiate sine x from first principle. You're going to see how to differentiate cos s from first principle. You're also going to see how to differentiate tan s from first principle.